Okay guys, so this is constructing redox equations, and this is the first of a two-part kind of episode. This is the easy way to do it if you're told quite a bit of information. If you're not told this much information, then you'll need to use oxidation numbers. So I'll put that up as constructing redox equations part 2. So this is part 1. This is if you're told quite a bit of information. Now there's 3 steps to what you need to do to balance a redox equation. First of all, we write out the ionic half equations. And you need to do 2, 1 for each species. Then we multiply each equation to get the same number of electrons in each equation, and I'll explain what that means in a second. We then combine the 2 equations and cancel out the electrons on either side. Because if you've done step 2 properly, you should have the same amount on either side. So first of all, let's look at our question. The question says, iron, Fe, is oxidized to Fe3. So these Roman numerals mean 3+. Oxidized, oil rig, oxidation is loss, so it's lost electrons to become a 3+ ion. And copper 2, so copper 2+, is reduced to copper. So that's gained 2 electrons, it's gone from 2+ to 0. So first step, I'm going to write out my ionic half equations. So let's look at what I've got. I've got iron, and that is getting changed into iron 3+. Well, let's balance out by adding electrons to one side. Obviously, I need 3 electrons there to balance the charges. I've also got copper 2, and that is getting changed into just normal copper, so Cu. So again, I need to balance it out by adding electrons to one side. But it's obvious I need to add 2 electrons there to balance my charges out. So all you do is add electrons to one side to balance out the charges. And a little tip to make sure you've got it right is if you add the electrons to one side of one equation, they're always added to the other side in the other equation. So what this is telling me is iron releases 3 electrons and each copper takes up 2 of those electrons. So I've constructed my 2 ionic half equations. I then need to multiply these by a certain number to make sure I have the same electrons in each equation. So what you need to do is look for a common multiple. So which number can 2 and 3 both fit into? Well, obviously the smallest number that 2 and 3 can fit into is 6, the smallest whole number, because you can't have half an atom. Therefore, I'm going to multiply this equation by 2 to get 6 electrons. So that's 2Fe goes to 2Fe3 plus 6E minus, and I'm going to multiply the bottom equation by 3. So you notice you don't have to multiply both of these by the same number. They probably will be different numbers. So multiplying this by 3, I get 3Cu2 plus 6E minus goes to 3Cu. And look, I've got the same number of electrons in each question now, or in each equation. Then the third step, I combine the 2 equations and cancel out my electrons. So on this side of the arrow, I've got 2Fe plus 3Cu2 plus my 6 electrons goes to 2Fe3 plus 3Cu, again plus my 6 electrons. But since I've got 6 electrons on both sides, I can cancel those out. If I was you, I just wouldn't write it in the first place, to give me my final equation, which is 2Fe plus 3Cu2 plus goes to 2Fe3 plus and 3Cu. And that is my balanced redox equation. What I'm going to do now is rub this off and put another question up. If I was you, I would pause the video now, have a go at doing the question yourself, and then once you think you've got an answer, press play again and see whether you've got it right. And I'll go through 2 more questions for this, just to get you a bit of practice at it. Okay, so my next question is going to be Cu2 plus 2E minus goes to Cu, Mn goes to Mn7 plus 7E minus. So I've done step 1 for you. Pause it now, have a go at doing step 2 and 3, and then press play again. Okay, so step 2, I need to find a common multiple of 2 and 7. Well, the lowest common multiple is obviously 14, so I'll need to multiply this side by 7 to get 14 electrons. So 7Cu2 plus 14E minus goes to 7Cu. And I need to multiply this equation by 2 to get 14. So that's going to be 2Mn goes to 2Mn7 plus 14E minus. I then need to combine my equations. So I'm going to combine everything on this side. 7Cu2 plus 2Mn. I'm not even going to bother with my electrons because I know they cancel out on the other side. If you can't do that, then put them on both sides, then just cross them out or rub them out. That might be easier. Then on my opposite side, I've got 7Cu plus 2Mn7 plus. That is my balanced equation, redox equation. I'll do another one now, one more. Okay, how about this one? Mn goes to Mn3 plus 3 minus, and CO2 plus 2E minus goes to CO. So pause it now, have a go at that, do steps 2 and 3, and then press play when you've done that. Okay, so we find a common multiple. Obviously, common multiple of 2 and 3 is 6. So I'm going to need to times this top equation by 2. So 2Nm, Mn, goes to 2Mn3 plus, it's a tongue twister, plus 6 electrons. 2 times 3 is 3O2 plus 6E minus plus 3CO. Combine my equations, your electrons will cancel because look, once again the same number on each side. That's the whole point of doing step 2. So 2Mn plus 3CO2 plus goes to 2Mn3 plus 3CO. And that gave my balanced equation. So that's the easy way. I don't think many people struggle with that. The next one I'm going to do, so part 2 of this, is definitely worth watching. That's the harder way. That's using oxidation numbers. So have a look for that on my links and see if you can find that now.